All right, this is sections 1.3 and 1.4. I'm looking at example 1.43. And here they just want us to solve a system. We have x1 plus x2 plus x3 is equal to 1. X1 plus, oh wait, I wrote that wrong. Okay, that's x1 minus x2 plus x3, and then x1 plus x2 minus x3 is equal to 2. And so we have our augmented matrix. I'm not sure why that got dark. We have our augmented matrix of 1, -1, 1, and 1. And then 1, 1, -1, and 2. And so I want to get rid of that 1 in the bottom left corner. And so to do that, I can replace row 2 with row 2 minus row 1. And so I have 1, -1, 1, and 1. And then 0, I have 1, and then plus 1 is 2, -1 minus 1 is -2, and then 2 minus 1 is 1, like that. Now I want that to be a 1, so we'll take row 2 and replace that with 1/2 row 2. So I have 1, -1, 1, 1, and 0, 1, -1, and 1/2. Now let's add row 2 to row 1 and put that in row 1. So row 1 gets row 1 plus row 2. And so I get 1, 0, 0, and 3/2. And whoops. And then down here I get 0, 1, -1, and 1/2. Okay, so at this point I have my reduced row echelon form because I can't do any more with anything to the right. I don't have any more rows to work with. And so this is x1 equals 3/2, and x2 minus x3 is equal to 1/2. Well, so if I'm writing that solution, whoops, that was kind of amazing. If I'm writing that solution, gotta watch where my hands hit, I guess. And so we have our x1 equals 3/2. X2 is 1/2 minus, plus, gotta watch my negatives there, x3. And then x3 is just some value, t or z or whatever, so let me say that's t arbitrary. And actually, since that's just an x3 there, I could replace that with a t. So I could write this as x1 equals 3/2, x2 equals 1/2 plus t. It's not a very good t, there we go. And then x3 is equal to, and I could write it as 0 plus t. Okay, so even, if you simply wrote that and then mentioned that x3 is arbitrary, that's okay too. I mean, that gets the solution across. Eventually, we're going to write things more like this one, and so that's probably not a bad habit to get into. something like this, this tells us that x3 is indeed arbitrary. But once we decide what t is, then we know what x2 is, and we always know what x1 had to be. Okay, so that is our system. We're not going to do example 1.44 on here. It's just bigger than we'd like. But let's go down here and look at example 1.4.5. And in this case, we're again given a system that looks like it shouldn't work, should be inconsistent, but they toss a little extra into this in that this last equation that looks like it's one too many, they put a t here and say, well, we don't know what that t is. And so we have an augmented system of 1, 1, 2, 1 minus 1, and 0, and 3 minus 1, and t. So this gets to be sort of a pain in the butt to work with, but nonetheless, I can do it. So the first thing I want to do is zero out my bottom rows on the left, and so I can replace row 2 with row 2 minus row 1. And I have 1, 1, 2, 0, and then negative 1 minus 1 is a negative 2, 0 minus 2 is a negative 2, and 3, negative 1, and t. Now, get rid of that 3, so we're going to have row 3 get replaced by row 3 minus 3 row 1. And so 1, 1, 2, 0, negative 2, negative 2, 0. Now I have negative 1 minus 3, that's negative 4. And then I have t minus 6. So it's t minus 6. That's what I'm stuck with. And now I want to turn my negative 2 into a 1. So row 2 gets negative 1/2 row 2. So that's 1, 1, 2, 0, 1, 1, and 0, negative 4, and t minus 6. Okay, now let's see. I'm just looking at something here. See, I'm looking at the textbook just to kind of make sure I'm not messing anything up too much. And I'm not sure I agree with their reduced or their row echelon form, not reduced row echelon form, but their row echelon form. I think they made a mistake, so I'm glad I'm doing this. We can also check this with Sage, but see, the problem is in their next step, they would say they go to a third row of 0, 0, and t minus 2. And possibly that's correct. However, I think it looks like what they did was they added 4 to both sides of that bottom row. And I don't think that's right. so, so I think, you know, what they ended up with there is incorrect. And because I'm pretty sure about that t minus 6. Did I do that right? Right, when I subtract 3 of these, right, that's 3 of these top rows here, then I get 3 times 2 is 6, but I subtract, so that's negative 6. Yeah, I'm pretty certain I've got that right. And so I think they messed stuff up. So now let's get down here and they want to know what t has to be to keep this consistent, and well, actually maybe they are correct, because what I notice here, yeah, so I'm not sure how they got to the 0, 0, t minus 2. We'll see if we get there. But t equal 2 in their answer will be correct. So let's keep going. So now I want to take row 1 and replace that with row 1 minus row 2, and get 1, 0, 1, like that. And then I have 0, 1, 1, and 0, negative 4, and t minus 6. Okay, now I would like to replace row 3 with row 3. Oh, yeah, okay, this is going to work. All right. Yeah, so much for my poor intuition. So for row 2, and we will get the t minus 2. Okay, 1, 0, 1, 0, 1, 1, and 0, 0. And when we take t minus 6 and we add 4, we get t minus 2. Yeah, see, what am I worrying about? Okay, so it is t minus 2. And so for this to be consistent, we need t minus 2 to equal 0. And so t must equal 2. But if t equals 2, we end up with the system 1, 0, 1, 0, 1, 1, 0, 0, 0. And this implies that x equals 1 and y equals 1. And we have a consistent system. But if t is anything, you know, if t not equal to 2 implies inconsistent. Okay, so I got a little scared back here, but no, it was correct. They were fine. And we see that we need t equal 2 to get a solution. And if t is not equal to 2, we have no solution. It's inconsistent.